Week 3, lesson 4. Okay, so this lesson's on word problems. So we have to actually take the stuff that you've learned about vectors and put them to use. So I'll let you pause the video and read the example. I don't need to read it to you, although the names of the boats are pretty funny. But anyway, I think I'm going to start by writing the two equations in a different form. So I'm going to write this R as -1 and 10 plus t times 2 over -2. And the other equation as 0,4 plus s times 2, 3. And there shouldn't be a line there. 2, 3. Okay, now the reason I like it in this form better is because it looks more like slope-intercept form to me, right? I have a starting point for both of them, and then I have a parameter, right? So the parameters right here, if you read in the problem, they represent time in hours, all right? And then this is considered to be the direction. So I know where the boat is, I know where it's going, and I know that it's going there in hours. Okay, so let me scoot this up. So it says, find the positions of the boats when they were spotted. Okay, that means when either t is 0 or when s is 0. Okay, so if you let t or s equal 0, then you've got the original starting point for each boat. So for this one and for this one. Okay, it also says the distance between them. So we just need to do the distance formula between those 2 points. X minus x will be 1, and y minus y would be 6. And breaking out your handy-dandy calculator, I believe you get about 6.08 kilometers. Okay, next, part B. Let me scoot this up just a little. Okay, part B says calculate the speed of the boat. Okay, so way up at the top, I know you can't see it on my screen, but I'm hoping you printed this out and you have it in front of you. Speed is the magnitude of the direction vector. Okay, speed is just the magnitude of the direction vector. So we need to find the direction vector for each boat. Right, so the first one is 2, -2, and the second one is 2, 3. And I need to find the magnitude of each. Okay, so that in this case, it's 4 plus 4, breaking out a calculator, that's about 2.83 kilometers per hour. Okay, notice that notation. It is slightly different than you've seen before, unless you've already taken physics. But this negative exponent right here it's the same thing as this. It puts it into the denominator. Okay, but you will see this a lot, especially those of you that are IB students. All right, so then we do the magnitude of the P vector, or the pretty sure boat. We get, what, 4 plus 9. Again, handy-dandy calculator. That's about 3.61 kilometers per hour. Okay, next part, and I'm going to move this up a little bit. Part C says, find the coordinates of the point where their courses meet. This does not mean necessarily that the boats are going to crash. It just means that there's a course for one boat and there's a course for a different boat, and there is a spot where their courses meet. We're going to find that. All right? And the way we're going to find that is if you, let me scoot it down so you can see just a little. If you multiply this and set it equal to this, that's sort of the equations involving the x direction. Likewise, we will take that and set it equal to that, right? So let me show you what that looks like. Wrong button. Let's try this. So I have negative, and I'm in the wrong color. This is not going well, you guys. Plus 2t equals 2s, along with 10 minus 2t equals 4 plus 3s. And this is set up really, really nice for these t's to cancel out. So 9 is equal to 4 plus 5s, or 5 equals 5s, or s equals 1. And if you plug that in, right, you go way back up here and plug it in, you should get an intersection point of 2, 7. Okay, now, I know some of you might be thinking, well, shouldn't I solve this for t now that I know what s is? And absolutely, if you want to do that, go right ahead. You will get t is equal to 3/2. And if you plug that into the other equation, the one that involves a t, you'll get the same intersection point. Okay, so then the very last question on this worksheet, well, not on this worksheet, on this example, is will the boats collide or not? Okay, so you kind of have to look back over here. For one of the equations, it takes 1 hour to get to the intersection point. But for the other boat, it takes 1.5 hours. All right, so again, going back to this picture over here, one boat is going and it's going to take an hour to get here. The other boat is going, but it takes an hour and a half to get to that same spot. So they're not in the same spot at the same time. So no, they do not collide. No collision. Okay, let's take a look at the second example. Let me scoot this up. Okay, every year Luke swims, you can read. Let me see if I can kind of use the picture that they have along with drawing my own. So if I have Z over here representing Zadar and P over here representing Preco, this is where, in the end, Luke is going to end up. However, there's a current going in this direction, right, that is perpendicular to the way he's going to swim. So he's not going to actually swim straight across because he'd end up over here somewhere. He's going to have to swim this way, right, at his rate of 1.8 versus this rate of 1.2 in order to end up over here where he needs to be, if that makes sense. All right, so question number 1, what angle in degrees? So this angle, and notice we are in degrees now. You may have to change your calculator. To the route should he swim to travel directly? All right, so that's literally, if you look really close, it is just a right triangle. If I did the sine of the angle, that's the opposite side over the hypotenuse, and I break out my calculator, I get 41.8 degrees. Okay, not too bad. The second question is, how long is it going to take? Okay, in order to figure that out, I actually need to know this, let me highlight it, this length. Okay, so the first thing I'm going to do, I'm going to name it V. All right, and then I'm going to do the Pythagorean Theorem to figure out what it actually equals. So vectors, that vector squared plus 1.2 squared should equal the hypotenuse squared. And again, break out your calculator. You should get 1.34 meters per second. Okay, so that is, that's his rate, right? All of the numbers that you're seeing here, these are all rates of meters per second. Okay, but we're trying to figure out how long it takes. So let me scoot this up a little. You guys have seen this before. Distance is equal to rate times time. It says that the distance is 4.5 kilometers. We know the rate as 1.34 meters per second. What we're trying to figure out is time. Okay, now I don't know if you're noticing, but this is going to be difficult to do with this being in kilometers and this being in meters. So I'm going to change the kilometers to meters. 1.34 meters per second times t. And if I divide by 1.34 meters per second, the meters cancel out and these seconds end up going up. And I forgot the number, 1.34. There we go. So, breaking out your calculator, 4,500 divided by 1.34 is about 3354.1025 seconds. Okay, read the problem. Question does not ask for this thing in seconds. It asks for it in minutes. Okay, so you're going to have to divide by 60. The time that you end up with should be 55.9 minutes.